Hi everyone, today we're going to learn about the quadratic relationship and its key features. As you can see from the graph, a quadratic relationship is going to look like a U. It can be a U that opens up or opens down. This shape is known as a quadratic relationship or a parabola. A parabola has a number of key features that we can use to identify it and to help figure out what our parabola will look like exactly if we plot it on a grid. The first piece is the vertex. The vertex is the maximum or minimum point on the graph, so it's at the top or at the bottom of the U. In this graph, you can see that the vertex occurs at 1, 8. The curve is going up until it reaches this point, and then it begins to fall. There's an axis of symmetry, which is a dotted line that passes through the vertex, and what it does is it illustrates the symmetry of the parabola. Remember that along an axis of symmetry, if you were to fold it, the two sides of the curve would line up with one another. Its equation for the line of symmetry is x equals, and then the x-coordinate of the vertex. So in this case, we'd have an axis of symmetry of x equals 1. The optimal value of a parabola is the highest maximum or the lowest minimum y value that a parabola reaches. We identify the optimum value using the y-coordinate of the vertex. So for this parabola, the optimum value will be y equals 8. We can also identify the x-intercepts, or the zeros, of a parabola. This is the location where the parabola passes through the horizontal or the x-axis. Typically, there are 2 x-intercepts for each parabola. In this case, we have one x-intercept of -1, 0, and a second of 3, 0. The y-intercept of a parabola is the location where it passes through the vertical or the y-axis. It can also be reflected in the axis of symmetry to find another point along the parabola. The y-intercept is always listed in the form 0, a number. In this case, the parabola has a y-intercept of 0, 6. The direction of opening of a parabola tells us whether the parabola is opening up or opening down. When we have a parabola that's opening up, it will have a minimum value. And when the parabola is opening down, it will have a maximum value. This parabola is opening down. Another feature of a parabola is its step pattern. The step pattern is a pattern that can be counted vertically for each one horizontal movement within a parabola. The step pattern will always be a multiple of 1, 3, 5. In this parabola, we can begin to count the step pattern. We can see that from the vertex, if we go over 1, we'll go down 2. And then from there, we can go over 1 and down 6 to find our next point along the parabola. If we were to keep going, we would need it to be a multiple of 1, 3, 5. Since we have a pattern so far of 2, 6, we know that the next one would be 5 times 2, or 10. So from the point 3, 0, we could go over 1 and down 10 to find the next point on the parabola if the grid allowed us to do so. Note that when a parabola is opening down, the step pattern will be made up of negative numbers. A way that we can tell if a relationship is going to be quadratic is to look at the first and second differences. As we know from linear relationships, when we have first differences that are all the same, we know that the relationship will be linear. When we want to look at a curve and decide if it's a parabola or not, we'll look at the second differences. If the second differences are all the same, then we know the relationship is a quadratic. So we can calculate the first differences for this table. We can see that for the y values, they begin going down 9, and then down 3, and then up 3, and then up 9, and then up 15, and then up 21. We'll calculate the second differences by looking at the first differences and how they change. So the first differences start at -9 and go to -3, which is up by 6. From -3, it goes to +3, which is again up by 6. From 3 to 9 is up 6, from 9 to 15 is up 6, and from 15 to 21 is also up 6. Because all of the second differences are the same, we can conclude that this relationship is a quadratic. As we begin to plot the points of this quadratic, we will do so by plotting the x and the y coordinates. After we've done that, we can start to look at the key features. The vertex of this parabola occurs at -1, -3. Its axis of symmetry that goes through the vertex is at x equals -1. Our optimal value is a minimum, and it occurs at -3. Our x-intercepts, or zeros, are -2, 0, and 0, 0. This point 0, 0 is also our y-intercept. It's the point where the parabola crosses the y-axis. The direction of opening is up. Step patterns need to be a multiple of 1, 3, 5. If we start at the vertex of our parabola, we can count over 1 and up 3. From there, we can count over 1 and up 9. If we were able to continue our step pattern, we would be going over 1 and up 15, since it is apparent that our multiple, or our factor of our step pattern here, is 3. We can't see this point on our graph because we would need more grid space to locate it, but we know where it would be if we had that space.